So this is the code right here that I use for module 2, the proximity lab. And then I'm gonna upload this to my Arduino. Done uploading. Okay, so we're gonna close that because we can't have both the code and the serial monitor open at the same time. And then in terms of my wiring for the circuit, we have the proximity sensor right here, and then we have some wires coming out of it. So first I've hooked into a voltage VCC that goes right to this plus bar on the left hand side of my breadboard, which then that plus bar is connected to 5 volts on my Arduino, and then conversely all the way at the other end of the 4 pins of my proximity sensor, we have ground, this blue wire, which then goes to the negative bar on the left-hand side of the breadboard, and then goes to ground on my Arduino. And then we have echo, denoted by the yellow, which echo is an input for the receiver. So that's going to produce output when the receiver gets a signal. So it produces output when the receiver gets a signal. But in the code, it's denoted as input. So then that's the yellow wire. So that yellow wire just goes straight to digital. That would be digital input pin 10 with the PWM, and then this right next to it, this green wire, digital output 9, right? Because now we're talking about trig, which triggers the signal. So then this green line goes straight to trig on the proximity sensor. So that's my experimental setup. Let's run it. So see, I've got my breadboard and my Arduino. Then we get this long tape measure stretching 190 centimeters along this table. So we're just going to connect via serial monitor. Okay, so now we start 10 centimeters. And then now we'll move back 20 centimeters. It's interesting, we seem to have interference in our sphere. Oh, there we go. Now we're on it. Then now 30. Now we're hitting 30, 31. Then we move back 40. And now we're hitting 40 perfectly. And then we move here 50. Then our serial monitor, we're hitting 50 perfectly. 60. Serial monitor seems like it's averaging 60. Fantastic. 70. And yeah, I'm gonna do out the rest of these, but I don't think that needs to be in the video. Okay, so I just wanted to talk about the code for a minute. So these first 2 lines of the code simply define where trig, the pin coming off the ultrasonic sensor, and echo pin, or echo, the pin on the ultrasonic sensor, are connected to. So digital outputs 9 and 10 is where they're connected. And then after that, we just define our start time as 0. Then our void setup, so what happens once. So here we're basically just defining the pin trig on the ultrasonic sensor as an output, and the pin echo as an input. And then this next line
serial.begin 9600. That just defines, starts the serial communication. And then we get into void loop, which then is going to occur repeatedly throughout the entire time the Arduino is plugged in. Sorry, that was unclear. So then we start with low voltage going through trig pin, and then a 2 microsecond delay, and then trig pin goes to high, so 5 volts are going to be going through trig pin for 10 microseconds when we say digital write trig pin high. And then after these 10 microseconds elapse, it's going to go back to low voltage going through trig pin or 0 volts. And then after that, we start to look at the echo pin. So the 5 volts is then going to pass through that. And then after this, we just have a calculation for the speed of sound, and then consequently the distance that the object is away from the ultrasonic sensor. And then after that, we have just some code towards the bottom here, so that the actual measurements do print on the serial monitor. And then actually one thing is changed from the uncalibrated code to the calibrated code. So in the calibrated code, rather than just having the distance, I put a line for uncorrected distance. So that was the initial distance. And then the second line, corrected distance. So that's using the equation I got in Microsoft Excel to correct that distance into the actual distance that's shown on a tape measure. So now with this new code, you should be able to get the ultrasonic sensor's measurements to match up with the measurements from your tape measure.